We're going to now do advanced empirical and molecular formulas, which is an SAT 2 concept as lesson 13. So first we're going to talk about the steps for solving advanced empirical formulas. We're going to practice percent to empirical formula and practice percent to molecular formulas. So calculating empirical formulas using percent compositions, we have to assume that the percent composition is equivalent to the grams of each element in a 100 gram sample of a compound. This will make it easy for us because then those percentages can just be turned into grams. So 40% of carbon would just be 40 grams of carbon. 6.67 grams of hydrogen would just be 6.67 grams of hydrogen. 53.3% would just be 53.3 grams. Then we're going to divide each element by its own molar mass, just the GFM. This will give you the moles of each of the elements within that compound. So now we're going to take that 40 grams of carbon divided by 12 grams per mole. Again, just straight out of the reference table. For hydrogen, it would be 6.6 divided by 1, and then oxygen would be 53.3 divided by 16. Then we're going to look for the smallest amount of moles. So you notice that the carbon and the oxygen both have the same amount, which is less than the hydrogen, 3.33 moles. So after we find the moles of each, we're going to divide all answers by the lowest number of moles. And again, the 3.33 was the smallest number. So we're going to divide all three of those values of moles by the 3.33. This will give us how many carbons, hydrogens, and oxygens were actually in the compound. So the answer you came up with will be the subscripts that we're going to use for the empirical formula. So this 1, 2, and 1 that you see ends up being 1 carbon, 2 hydrogens, 1 oxygen. So it gives us the empirical formula of CH2O.
So let's try this practice problem. In our given information, we know that we have a compound of zinc and phosphorus, and when analyzed, it shows that we have 76% zinc and 24% phosphorus by mass. We're going to calculate the empirical formula for this compound. So step 1 is convert percent into grams. 76% makes 76 grams, 24% makes 24 grams. The second step is to take the grams of these elements and now divide it by their GFM to figure out how many moles we have. So 1 mole of zinc is 65.4 grams. We don't know how many moles that is, but we have 76. We have 1.16 moles of zinc. For phosphorus, we know that 1 phosphorus weighs 31 grams. We have 24, so therefore we have 0.774 moles of phosphorus. We're also noticing that our phosphorus is our smallest amount, so therefore we take the moles that we just calculated in blue, and we're dividing it by the smallest number. We get 1.5 moles of zinc, and we get 1 mole of phosphorus. Finally, we realize that we get a formula that is Zn 1.5P1. Zinc itself cannot have 1.5 moles of itself, which is impossible. So we have to figure out a way that we can then change the number equally on both sides. So therefore, if we multiply everything by 2, we get the formula Zn3P2. To check yourself, you could look up the charges zinc and phosphorus. Phosphorus is a -3, zinc is a +2, and when you do the crisscross method, you get the formula Zn3P2.
So here's another example where we have 40.5% zinc, 19.9% sulfur, 39.6% oxygen, and we're trying to find the empirical formula. Convert all those percents to grams. So we get 40.5 grams of zinc, 19.9 grams of sulfur, and 39.6 grams of oxygen. Then we're going to convert those grams into moles by dividing them by their GFM. So 40.5 grams divided by the 65.4, we end up with 0.619 moles of zinc. Same thing you would do for the sulfur and the oxygen, and as you can see, the numbers that we get. Remember to find the smallest value of moles from this. Then in step 3, divide each and every one of the answers that you got in step 2 by the smallest number. So you'll end up with 1 mole of zinc, 1 mole of sulfur, and 4 moles of oxygen. Now we use those as the subscripts to write our formula. So we end up with ZnSO4. We can then check our answer by remembering our rules for ionic compounds. Now this is ternary, so zinc has a +2 charge, SO4 has a -2 charge, so this is the formula that we should find.
Now, let's try to take our empirical formulas and then convert them to molecular formulas. So we have a compound of phosphorus and oxygen, and when we analyze it, it shows that we have 39.24% phosphorus and 60.78% oxygen. Step one is convert your percentages into grams, which we do right here. We're noticing that we have 1.2 moles of phosphorus and 3.8 moles of oxygen. We then see that we have less phosphorus because that's the smallest amount, so we divide both of our moles by the smaller number. Therefore, we get 1 mole of phosphorus and 3 moles of oxygen. When we put that into a formula, we get PO3. So now we have our empirical formula, which is in green. PO3 is in our empirical. And now we want to find out what the actual molecular formula is if the GFM of the compound is 158 grams. So the first step we have to do is find out the GFM of our empirical formula, which comes out to be 79 grams. We know our molecular formula is 158 grams, so we take molecular divided by 79, and that tells us it's going to be 2 times larger. So then we take our empirical formula of PO3, we multiply all the coefficients by 2, and we get our final formula of P2O6. If you were to check your work, you would take the GFM of P2O6 and make sure it comes out to 158.0 grams.